CCC Tutor Rebecca, and today I'm going to be going through some examples of completing the square. Now, the first question is, why do we usually complete the square? And the easy answer for that is to put a polynomial into what they call vertex form. Now, we're used to our regular form of polynomials being that y equals ax squared plus bx plus c form. And now there's a lot of good information we can get about our parabola, which is the graph of a polynomial here. There's a lot of information we can get from this particular form, the regular form. However, there's information that we can only get from vertex form. Now, vertex form is written as y equals a times x minus h squared plus k. And now, the reason we put a polynomial in vertex form, we move things around to get it into this form, because the vertex, or that high point or low point of our parabola, is going to be found at the point positive h, comma, k. Now notice that the h here and the h here have different signs, and I tell students to just take those very literally. If we had a positive 2 here, that would make this a negative 2, but in our vertex here it would still be positive. So just a couple of things to remember. So now, vertex form we cannot get from our regular form of the polynomials. So completing the square is how we take a polynomial in regular form and put it into vertex form. So I have 4 examples of completing the square, increasing in difficulty. And I'm going to walk you through all of them. So to start off, I want to start with a pretty simple one. And that will be y equals x squared plus 6x plus 2. Now, the first step here is to recognize that if we're going to be putting this into vertex form, we are not going to be using y, rather we're going to turn that into a 0. So to rewrite this, I'll write this as x squared plus 6x plus 2 equals 0. And we need the other side of that equal sign to be free so we can move some stuff around, because that is going to be our first step. The first step here will be to subtract 2 from both sides. That frees up some space for us to complete the square in the middle. So to rewrite, we have x squared plus 6x. I'm going to leave myself a little space because we're going to put something here, and that's going to equal negative 2. Now, what are we going to be putting in that space? Well, there's a very simple, very small formula that helps us get to that point. So remember that this term here, our 6x, is our b term of our original polynomial, and the formula goes something like this. We have b over 2 squared. Very small, very simple. Now, what this is going to do is it's going to help us figure out what we're going to put here. But it's also going to help us figure out what our eventual square is going to look like, and I'm going to show you what that means. So in this case, our b over 2 squared is going to equal 6 over 2 squared. Let's go ahead and simplify that fraction in the middle first. That's going to give us 3 squared, which of course equals 9. So that 9 is going to come back right here. We are going to add a positive 9 in that space. Now, the key important thing to remember here is that we are not trying to change the value of this polynomial. We want it to be the same parabola if we were going to graph it. And to do that, we need to make sure we don't change the value of any of these numbers. And to do that, we have to do the same thing that we do to one side of the equal sign on the other side as well. So if we've added a 9 on the right-hand side, or on the left-hand side, we are going to add a 9 as well on the right-hand side. That's very important. If we don't do that, we're definitely going to get the wrong answer. So to rewrite, we have x squared plus 6x plus 9. Let's rewrite that better. Plus 9. And that's going to equal negative 2 plus 9 is a positive 7. Now let's come back to this guy right here. I remember I told you that we were going to need it for another place. Now is that time. To be quite frank, the part of this in the middle, this b over 2, is going to end up being the value that is inside our completed square. And let me show you what that means. Right here, we now have a perfect square polynomial. And what that means is we can break this down into x plus something squared. Okay? And that was the whole goal of completing the square. And what I can tell you is what goes in here also goes in here. And it makes it really simple. We don't have to figure out what the factorization of x squared plus 6x plus 9 is. We just take whatever we got inside there before we squared and put it inside our square there. So to do that, we have a 3 here. That means we have a 3 here. And let's finish copying over everything. We also have a 7 over here. So now there's 2 ways we can go at this point. At this point, we have officially completed the square, but it depends on what kind of instructions your math problem, your test, your homework is telling you. And for the first option, if your instructions were only to complete the square for the polynomial, your next step would be to subtract 7 from both sides. Notice that I put it here under this blank space rather than under here because we're not going to be subtracting that 7 from anything inside those parentheses. So to rewrite, we would have y equals x plus 3 squared minus 7. And if we look back real quick, that is indeed in vertex form. Y equals a times x minus h squared plus k. And we do have that form here. To point out as well, here is our h term, here is our k term. Remember that that original formula said x minus h, which means that whatever we have in that h position, we're going to change the sign. So our vertex point here, if we know that it is positive h comma k, will end up being negative 3 because we've changed the sign, and negative 7 because there's no need to change the sign for the k. So that's our vertex point there. And if our instructions were simply to complete the square, this right here would be our answer. Now I want to go back real quick to where we were here because like I said, there's another option, and that would be if your instructions were to solve the equation by completing the square. Now I'm going to copy this. We're going to take it to the next page. And we are going to solve this equation from this point. Come on. Oh, whatever. I'll rewrite it. We had x plus 3 squared equals 7. Okay, so from here, to solve this equation, hopefully the first thing that you can see here is that we have a square on this side that we need to get rid of. And to do that, we would simply take the square of both sides. Now, if you've been in my study group before, you will remember that I've made it very important to point out that if you are taking the square root of both sides of an equation, it's important to remember that for the side that you're not using the square root to cancel, like we are here, meaning this side, you're going to also consider both positive and negative answers for that square root. So we've canceled the square on the left side. Let's rewrite. We have x plus 3 equals the positive or negative square root of 7, which is not going to be a nice number, so we're going to leave it like that. Now only one thing left to do to solve for x. We subtract 3 from both sides, and we get x equals -3 plus or minus the square root of 7. You can also write that as two separate equations. One would be x equals -3 plus the square root of 7. The other would be that -3 minus square root of 7. Now that would be the end goal. This here would be your answer if your instructions were to solve the equation by completing the square. Notice that if we have a positive and a negative solution, that will give us two real, though not nice, roots for our parabola. Those are two solutions. So that was the relatively straightforward completing the square practice. Let's move on to some problems that are a little harder. So the next step up is to throw some fractions in here. I like to show students examples of fractions because they trip people up a lot. So for this problem, we are given y equals x squared minus 3x minus 3 over 2. Now, just because there are fractions here does not mean that we're going to change our process. So we're going to take the same first step that we did last time. We're going to change that y into a 0 and move over this term here, the c term. So I'm going to do that all in one right. Hopefully you're on the same track. So that will be x squared minus 3x. I'm going to leave my space, and that's going to equal positive, because I've added it to both sides, 3 halves. All right, so same next step. We're going to take our b value there, that -3, and we're going to put it into our little formula. We've got -3 over 2 squared. Notice that that fraction in the middle does not simplify, so I'm going to write out my fraction math because I don't like to do fraction math in my head. So that is going to equal -3 over 2 times -3 over 2. Of course, the tops go straight across, we get +9. Bottoms go straight across, we get +4. Non-simplifiable. So we're just going to straight add that guy in, 9 over 4. Now remember, whatever we do to one side of the equation, we have to do to the other, so we're going to add 9 over 4 on this side as well. So let's rewrite that. We have x squared minus 3x plus 9 over 4, and that's going to equal 3 over 2 plus 9 over 4. So remember, we don't have to worry our heads about how to factor that left side. We already know what's going to go in that perfect square. Let's go ahead and write that. Oh, I just realized I totally forgot to take the square root of this. Oh no, I already did that. I'm losing my mind. Okay, we're on the right track. Right, exactly, because what we have in the middle there is x minus that 3 over 2, right here. So that's going to be squared, and that will, of course, equal this math that we have here on the right side. Now, before I rewrite that, I'm going to do that fraction math above. And to do that, we need the same common denominator. I can see here that 4 will be the easiest one to get to. So to make the same common denominator, we're going to change that 3 over 2 to have a denominator of 4. And the way that we do that is we need 2 times 2. And whatever we do to the bottom, we also have to do to the top. So we get 2 times 3 equals 6 over 2 times 2 equals 4. Plus 9 over 4. And that is, of course, going to be 9 plus 6 is 15 over 4. So let's rewrite that. We've got x minus 3 over 2 squared equals 15 over 4. Also not simplifiable, so all we're going to do is to complete the square. Let's say our instructions were simply to complete the square. We would move that over by subtracting 15 over 4 from both sides. And we would end up with y equals x minus 3 over 2 squared minus 15 over 4. And that is our completed square. I'm not going to solve this one through to the end because we're trying to keep this one a little shorter. But it will follow the same process that we did last time. You'll take the square root of both sides, consider the positive and negative, simplify that square if you can, and then solve for x. So that was level 2. Let's kick it up one more notch and introduce another complicating factor, but don't be nervous. We're going to go through it together. So for the next problem, we have a little bit of a different case. Our problem here is y equals negative 3x squared plus 6x minus 1. Now, the difference here is the previous problems that we've done had 1 in that a position in front of that x squared. In this case, our a term is not 1. It is a number that's not 1. And so that's going to change a little bit how we do this. For this problem, it's going to proceed relatively smoothly, and I'll show you how that works. So let's go ahead and skip through. Hopefully by now you recognize that the first 2 steps are to change y to 0, to move that 1 over, so let's rewrite it at that point already. We've got negative 3x squared plus 6x. We've got our space, and we are going to set that equal to a positive 1, which we've added to both sides. Now, we have to deal with that negative 3 before we do our b over 2 squared thing. And don't ask me why, I'm just a tutor, but I can tell you that we just have to deal with it first. So the easiest way to deal with it is to try and factor it out, and in this case that works out pretty nicely because you can see both our a term and our b term have a factor of 3 and even negative 3. So we're going to do that. We're going to factor a negative 3 out of the the left side of our equation here. So that's going to look like negative 3 times x squared. Now remember, if I've factored a negative out of a positive, that leaves me with a negative 2x. I'm going to leave my space here, and that's going to equal 1. Now, the key to remember is that when we're factoring something out, we're not changing anything about that side of the problem. We're just rearranging some of the values, so we don't have to do that to both sides. Just the one side is going to be factoring the 3 out. Okay, so now inside those parentheses we have an a term that is 1, and that is now where we can start moving forward. So let's take that next step, right? That b over 2. That's going to be negative 2 over 2 squared. That's of course going to equal negative 1 squared. And I like to remember to keep my parentheses at this point because sometimes it's hard to remember which comes first, the negative or the square. This way you can see really easy. It's going to be negative 1 times negative 1. That's going to equal positive 1. So that guy's going to go right up here. We're going to add 1. Now here as well, something a little different. Let's take a good hard look at that left side. We may have added 1 inside the parentheses, but notice that that negative 3 is still outside and multiplied against everything that's in those parentheses. If we were going to go backwards and distribute that negative 3 back through, we would get negative 3x squared, our positive 6x again, and also a negative 3 from that negative 3 times that positive 1. And what that means is, in order to do the same thing to both sides, we're not going to add a positive 1 to the right side of our equation. We're going to add a negative 3. Hopefully that makes sense. Essentially, the idea is if we have an a value out here in the front, whatever we add in here is changed by that multiplication. So just keep that in mind, okay? All right, so let's rewrite. We've got -3. Remember that this guy here is going to become our squared term. So that's going to be x minus 1 squared. And that's going to equal 1 minus 3, which is -2. Let's finish it out and complete the square. We will get y equals, actually let's add 2. We will get y equals -3 times x minus 1 squared plus 2. So even though that a term does kind of complicate things a little bit, it's pretty simple once you know how to handle it. So make sure that you're remembering to adjust that added number for whatever you've got in your a term. Again, completing the square, or solving this equation by completing the square here is pretty straightforward as long as you follow PEMDAS, so I'm not going to run through this one to the end either. Let's move on to the next step. Hopefully you're still with me. Our next problem is going to be our hardest one. So if this makes sense to you, you're probably on a good track to be doing well with completing the square. Okay, so for this last one, our equation is going to be y equals 3x squared plus 4x minus 1. Alright, so notice first off the bat, we do have a 3 in our a term here, which means we know we're going to have to factor it out. But notice that our 4 there, unlike the 6 in the last problem, does not factor nicely. So we might have some fractions in this one, so prepare yourself. Alright, so let's go ahead and do those first steps. Change the y to 0, move that c term over. We're going to skip right to the end of that. We will get 3x squared plus 4x equals positive 1. Alright, and I haven't included my space here because we're going to do our factoring first. And we are going to still factor a 3 out of here, even though that makes our b term a fraction. It's more important to get that a term down to 1 inside those parentheses. So we're going to do that. If we factored a 3 out of that left side of the equation, it would look like this. We would get 3 times x squared plus 4 over 3x, leave our space here, equals positive 1. Alright, same steps as before. We're going to do our b term over 2 squared. That's going to give us a complex fraction, but don't get too rushed with it, and I'm sure it'll be just fine. So, if we have 4 over 3 over 2 squared, remember, if it's very tall, we want to make it horizontal. That's going to equal 4 over 3 divided by 1 over 2. Sorry, other way around. Divided by 2 over 1. And that is all going to be squared. Let's do our dot flip there in the middle. We get 4 over 3 times 1 over 2 squared. And if we did that multiplication, 4 times 1 equals 4, 3 times 2 equals 3, we get 4 over 6, 4 over 6 squared. Let's write out our fraction math because I don't like doing it in my head. That'll give us 4 over 6 times 4 over 6, and we get 4 times 4 is 16 over 6 times 6, which equals 36. Oh boy, let's see. Both of those are at least divisible by 2, which will give us 8 over 13. Nope, sorry, 18. 8 over 18, which simplifies to 4 over, let's see, 9. Yeah, 4 over 9. All right, so that is going to come all the way back up to here. And we're going to add 4 over 9 inside. Now remember, we do have an A term that is not 1, and that's going to adjust what we've added. So we need to do 4 over 9 times 3 over 1 to figure out what we're going to put on that right side of the equation. Straight across the top, we get 4 times 3 equals 12 over 9. Both of those are divisible by 3. We get 4 over 3. All right, and that is what's going to go right here, plus 4 over 3. All right, I know this is way up here. Let's rewrite it back down at the bottom. We get 3 times x squared plus 4 over 3x plus 4 over 9 equals 1 plus 4 over 3. All right, so we know how this simplifies down. We need that simplification of this, right? Where was the end of that? Oh yeah, right here. Oh, sorry, nope, it was right here. There we go. Because it's always going to be before you do that square. That's a good place to look for. All right, so let's rewrite at least the right side of that equation. The left side, again. We get 3 times x plus our term there, which was 4 over 6, which actually simplifies down to 2 over 3. I hadn't even realized that before. 2 over 3, of course, we want to simplify wherever we can, squared. And that's going to equal this math we have on the right side. Now, if we were going to add 1 to 4 over 3, remember that's technically 1 over 1, which means we can turn those 1's into any number we need to, i.e. that denominator, in order to be able to add. So I'm just going to replace this with 3 over 3. So that we can add it to 4 over 3. So now 3 plus 4 equals 7 over 3. I don't have enough room to rewrite this, but hopefully you're getting the gist enough to see that we will subtract that 7 over 3 from both sides, and that will leave us with our vertex form problem. Just for the heck of it, I will go ahead and solve it from this point for the last one. That is going to happen on the next page, though. So we've got 3 times x plus 2 over 3 squared equals 7 over 3. Okay, so if we were to follow PEMDAS, we're going to go from parentheses, exponents, all that kind of thing. If we followed PEMDAS, we would end up foiling that squared term, though. And to me, that seems a little bit more difficult than necessary. So I'm going to show you the way that I would do this, which would be to divide both sides by 3, first off. Right, and if we divide this side by 1 over 3, divide that by 3 over 1, thinking ahead of myself, that will, of course, dot flip to become 7 over 3 times, ooh, goodness, what happened there? Get out of my way. So it will become 7 over 3 times 3 over 1. Times 1 over 3, of course. Dot flip, right? Dot flip. There we go. Okay, 7 times, let's rewrite all this, right? Those 3's are going to cancel. We end up with x plus 2 over 3 squared equals 7 times 1 on the top there is 7. 3 times 3 on the bottom there is 9. All right, so we now go into our next step, which is to get rid of that square root. We're trying to get closer and closer and closer to our x value, of course. So we're going to take the square root of both sides. Remember, this will give us a positive and a negative on this side, and it will cancel our square here. Let's rewrite. We get x plus 2 over 3 equals plus or minus the square root of 7 over 9. Which, just in case you're not familiar, can also be written like this, square root of 7 over square root of 9, which, of course, on the bottom there, the square root of 9 is just 3. So let's simplify that. Okay, and of course the top square root of 7 there is not going to simplify, so we're going to leave that. Our last step to get x on its own is to subtract 2 over 3 from both sides, and we get x equals negative 2 over 3 plus or minus square root of 7 over 3. Now that addition and subtraction can't be done because we don't necessarily know what that square root of 7 will be. It's not a nice number. However, as you can see, our denominators are the same, which means we can combine this fraction to make it look a little nicer. So in essence, our end answer here will be x equals negative 2 plus or minus the square root of 7 all over 3. And that would be your answer. So, from the beginning to the end, hopefully you've been keeping up. If this last problem made sense to you, you are probably prepared to do most completing the square problems. So give it a try on your own, and if you have any questions, of course, email the tutoring website, email our tutoring inbox, of course, to get some extra tutoring from me. Thanks for sticking around and watching. I appreciate it.